Okay, here's video number 5 for reviewing the IF standard for the Spring 2019 final review. Remember, this is not an all-inclusive list of concepts. You are always responsible for reviewing everything we've learned this entire year. Next part on to IF. We're fully analyzing. We're going to factor and analyze the vertical asymptotes of holes of this function right here. So that is this function on the review, and then we're going to talk about the tangent function right here and all of its features before we go on to the next video. Okay, so let's factor this one. Let's see, we have a greatest common factor of x, so we're going to take that out. X squared minus 3x minus 18, and a greatest common factor, no numbers, but it's x squared, and we can factor out, we've got another trinomial left in there, x squared plus 10x plus 21. Now we can do magic x factoring. I'm going to write it above and below so we can see it right here. This looks like it's minus 6 plus 3. Being able to do that kind of factoring that quickly, immediately, mentally in your head is going to be a very useful skill. This one looks like it's plus 7 plus 3. Okay, so that's gone and that's gone. So let's just rewrite what we've got left here. X times x minus 6 times x plus 3. All of that divided by x squared, x plus 7, and x plus 3. Why don't we write this x squared as x times x? We can see there is a hole at x equals 0. There is a hole at x equals negative 3. Not going to be another vertical asymptote here because there's already a hole there, but we do have a vertical asymptote at x equals negative 7. Remember the h lies concept for finding the 0 of this denominator. The vertical asymptote is going to be at negative 7, hole at 0, and negative 3. And just for giggles, that would be what? That would be the x-intercept. Okay, if x is 6, that's going to make the numerator 0. That would be an x-intercept. Okay, now let's go on and talk about the tangent function really quick. What are the features of this graph? If you remember from the book, it's defined, its principal definition is from negative pi over 2 to pi over 2, and it kind of looks like this. And you've got inflection points where it changes its slope right there at 1 and negative 1. So the domain is going to be from all reals except where there's pi over 2's, plus or minus n times 2 pi. I think that's how they wrote it in the book. So the domain is all reals except x cannot equal pi over 2 plus or minus n over 2 pi, so, or n times pi, because that's where we're going to be dividing by 0. That's where the vertical asymptotes are. The range is going to be all reals from negative infinity to positive infinity. What's the period? What's this distance right here where it repeats values? Now, the period, remember, is pi of tangent. The period of sine and cosine is 2 pi. The period of tangent or cotangent is going to be pi. Where are the vertical asymptotes? Well, isn't this where, just remember, basically tangent is sine over cosine. So the vertical asymptotes happen when cosine equals 0. So where are the vertical asymptotes? Anytime cosine equals 0, like at negative pi over 2 or pi over 2. What about when is it increasing or decreasing? The tangent function is always going to have this shape over every interval. It's always increasing. Okay, so those are some questions you can answer to help answer real life questions, or just basically features about the graph can help you to understand. And just for giggle's sake, let's talk about cotangent over here. Cotangent has a lot of the same things, except its domain is it can't be where the pi's are. Its period is also pi. Where the vertical asymptotes for cotangent is where sine equals 0, because cotangent, remember, is the reciprocal of this. And is it increasing or decreasing? Cotangent is always decreasing. Just remember the difference between those. All right, that's it for this one.